Hey guys, what's up? We are back here with day 2 video. Good job on watching and taking good notes on your day 1 video and dealing with the problems we had in class. It was excellent work. In day two's video, I want to talk about dealing with vertical asymptotes when we're talking about limits. And I also want to talk about solving limits as functions. How can we do this without a graph? Okay, so first off, with dealing with vertical asymptotes, when we work with limits as we approach a vertical asymptote, we can get a variety of answers to those problems. Let's go ahead and look at the graph real quick. If you want to just go ahead and pause the video for a second right now and sketch this graph into your notes, it'll be easier than trying to listen to me and sketch the graph at the same time. Okay, we're back. What I showed you here is a graph that has 3 different vertical asymptotes on it, and we're going to deal with limits at each of those as we approach each of those different x values where those vertical asymptotes occur. So our first one is, we'll just work left to right here. My first question is, what do you think the limit is as x approaches -4? We'll go ahead and label this graph as f of x. So our first question here is, what is the limit as x approaches -4? And again, we talked about this in day 1's video. Because we don't see any superscript after the -4, right? We don't see -4 plus or -4 minus. Whenever we see that, we have to, in our head, consider both the right-hand limit, the plus, and the left-hand limit, the minus. So let's kind of do that analysis here at -4. First thing, let's find x equals -4. So we're talking about this one right here. So let's consider first off, let's think about the left-hand limit. As I approach -4 from the left, from the more negative side, right, what I see is we have this vertical asymptote, and my y value keeps getting higher and higher and higher, right? So my limit as x goes to -4 minus, appears to be positive infinity. Okay, that's the left-hand limit. Let's take a look at the right-hand limit. Limit as x goes to -4, but approaching from the right side. When we approach -4 from the right side, we can see that our asymptote is directing us down towards -infinity. So what we see here is a left-hand limit of infinity and a right-hand limit of -infinity. Those are most definitely different from each other. Our big definition with limits is for a limit to exist, the right-hand limit and the left-hand limit must equal each other. Here they do not. So what that tells us is the limit as x goes to -4 does not exist. So sometimes when we see vertical asymptotes, that's probably the most common type of vertical asymptote we see. One side goes up, one side goes down. They're not approaching the same numbers from the left and right. One's positive infinity, one's negative infinity. Therefore, the limit does not exist. Let's take a look at a different one. Let's take a look at the limit as x goes to 3. So when we take a look and we find x equals 3 on here, this vertical asymptote right here, we should notice something a little bit different. When we think about our left-hand and right-hand limits, again, because there is no superscript up here, I have to think about both and see if they match. My left-hand limit at 3 is going towards negative infinity. My right-hand limit is also going towards negative infinity. Therefore, I'll say the limit as x goes to 3 equals negative infinity. Now, mathematicians have disagreed. Some mathematicians think that anytime we have these vertical asymptotes, the limits do not exist. But the general consensus is if you have an asymptote like at x equals 3 there, both going down, we can say the limit as x goes to 3 is equal to negative infinity. Take a guess now what the limit as x goes to 6 would be. Again, anytime we perform limits, if we don't have a superscript after the number, right, no plus, no minus, we have to think about both the left and the right-hand limits. Looking at this one, we can see that the left-hand limit is going to infinity. The right-hand limit is also going to infinity. Therefore, we know that the limit as x goes to 6 of f of x should be infinity. Okay. So when we see those vertical asymptotes, we could get a limit that does not exist. We could get a limit that is negative infinity or a limit that is positive infinity. So we'll see some more of those on graphs tomorrow, as well as a review of some of the day one stuff we looked at. Okay, let's talk about solving limits as functions. This is also interesting. So I have a few problems for you here. These problems look pretty similar to the problems that I gave you on the looking ahead part of your homework. So our first question here is the limit as x goes to 1 of the function 2x plus 5. So when I like to learn something new, I like to go back to something that I already know. So what I want to think about here is, okay, it would be helpful to have a graph. Well, I'm just going to use my graphing calculator here to call up a graph and kind of interpret this thing based on the graph. So go ahead and get your graphing calculators on and do this all with me. If you don't have it with you right now, just come back and try it later. So I'm going to go ahead and graph the function 2x plus 5. So I'll go to my calculator. Oops, hold on. I'll hit my y equals button, and I'll type in the graph 2x plus 5. Predicting what this graph will look like, I know it has to be linear. It's got to have a slope of 2, a y-intercept of 5. So here's what my graph looks like. And I'm thinking about what is the limit as x goes to 1? Well, if I take a look at this graph right here, just follow my cursor for a second. The limit as x goes to 1, we can tell by looking at this graph that a right-hand limit and a left-hand limit are approaching the same number. Okay? So it looks like this limit is going to exist. So what I want to figure out is, what y value are we approaching here? And when I look at it on this graph, this is 5, the y-intercept, right? Something looks weird here. Oh, whatever. So it looks like I'm approaching a y value of about 7. Okay. I can confirm that by I can go ahead and trace this. Right, so go hit the trace button. And let's just trace the number 1. And I see a y value of 7. And it's obvious to me that since this is a linear function, approaching from the right, approaching from the left, I'm approaching at the same number there. I don't have a vertical asymptote or anything weird there. And I'm getting an answer of 7. Okay, so one way that we can solve limits, if we know we have a nice, we're eventually going to refer to this as a continuous function. If I have a nice continuous function, I can just plug in 1 into my equation. So I can do this without using my graph. Okay. So I know the answer here is 7. Okay. And one way that I can solve is I can just take the x value that I'm doing my limit at and plug it into my equation. When I do that, I get 2 times 1 plus 5 equals 7. So one method for solving limits of functions is just to go ahead and plug in and see what we get. Let's try that with our example number 2. Example number 2 says I want the limit as x goes to -2 of x squared minus 4 over x plus 2. Okay, a little bit of rational function here, a little bit more complex, but let's try plugging it in and see what happens. If I take this -2 and plug it in for my x's, that's going to make -2 squared minus 4 over -2 plus 2. What happens is I get -2 squared is 4. 4 minus 4 is 0. And on the bottom, I get -2 plus 2, which is 0. So I get 0 over 0. We know in math that dividing by 0 creates things that are undefined. -2 is undefined in this rational function. However, I want you to think back, channel your inner pre-calc self. When we got 0 over 0 in our rational functions, what did that create? Did it create a vertical asymptote? Did it create an x-intercept? Or did it create a hole? Ding, ding, ding. Okay. So this is creating 0 over 0 oftentimes creates a hole. So what I want to look at is let's analyze this graph and see if it actually looks like a hole on the graph. So I'm going to go change my function. We all know that we hit alpha y equals enter to create our fraction bar. And on top, I've got x squared minus 4. And on bottom, I've got x plus 2. Okay. When I take a look at this graph, I get something that looks oddly linear. Interesting. Well, let's go ahead and trace -2 and see if that gives us the answer. When I trace -2, it says x equals -2, y equals blank. That is because -2 creates this rational function to be undefined. The question is, how could I use my graph, right? When I look at this, when I see -2 here, when I follow that down, it looks like maybe it's around -4. It looks like a limit's definitely going to exist here because we have a hole. We know from yesterday, or from Monday, that holes will still have limits. Like even though the function's undefined, the limit definitely will exist here. Well, what's a way that we could maybe use this trace screen to help us figure it out? Well, how about instead of plugging in -2, I plug in a number really close to -2. Like -1.5, or even better, how about -1.9? Let's trace -1.9. When I trace that, I see my y value comes out to -3.9. Well, I can get even closer than that. And again, because I'm using a number slightly bigger than -2, I'm approaching from the right side. -1.9 has created -3.99, right? And I can get even closer from this side. And I see, oops, not 1.999, -1.999. I see I keep getting closer and closer. I get -3.999. I know that that's a number really close to -4. But that's like doing my right-hand limit. Let's try a number a little bit less than -2, like -2.0001. And I see -4.001. So what I'm seeing here, let's go back to our notes. What I'm seeing in this graph is this. seeing something that looks like this. So this is telling me that as I approach -2 from both the right and the left, my y value I'm approaching is -4. So this limit appears to be -4. The question is, how can I do this without plugging it into my graph? Well, one of the techniques that we're going to talk about is factor and cancel. Is there anything in here that factors? Well, I know that x squared minus 4, x squared and 4 are both squares. So I can use a difference of squares here to factor this into x plus 2, x minus 2. For simple difference of squares factor. And on the bottom, I have x plus 2. Again, I'm still doing the limit here as x approaches -2. What I see now is that I can cancel this x plus 2 on the bottom and this x plus 2 on top. After I cancel, I'm left with x minus 2. So what I want to do now is plug in this -2 for x, and lo and behold, I get -2 minus 2, which equals -4. That's how I can get that answer without using a graphing calculator. Take a look at this problem real quick, problem 3. Let's talk about how we would solve this one. Let's try and do this one entirely without a calculator. Okay? If you want, pause it now. See if you can figure it out on your own. Okay. First thing I want to do is plug in 4 and see what I get. When I plug in 4 up top, I get 4 squared, so I get 16, minus 3 times 4 is 12, minus 4. 16 minus 12 is 4, 4 minus 4 is 0. And on bottom, I get 4 squared is 16, minus 7 times 4 is 28, plus 12. 16 minus 28 is -12, -12 plus 12 is also 0. So I'm getting 0 over 0, which is telling me it's likely a hole in my graph. So what I want to do now is I want to try factoring and canceling to see if that'll work again, and then see if I can solve this by hand without touching my calculator. I'll use my calculator to confirm. When I look at this doing the RS method, I see, okay, I want two numbers that multiply to -4, but add to -3. That would be a -4 and a +1. So I'm going to factor this top into x minus 4 and x plus 1. Okay, I'm just factoring this right here. Got to be really strong with RS. I also want two numbers that multiply to 12 but add to -7. And they're both going to have to be negative. That's going to be -4 and -3. What I see here is I have a factor of x minus 4 on both the top and the bottom. So I'm going to go ahead and cancel those out like I did before. And now I'm going to plug in 4 into this. So I'm going to get 4 plus 1 on top for this. And I'm going to get 4 minus 3 on the bottom. That gives me 5 on top, 1 on the bottom. So I should get an answer of 5. Let's use our graph to confirm that real quick. And then we'll be done for today. Okay, on top I want x squared minus 3x minus 4. And on bottom, I want x squared minus 7x plus 12. This is a weirder looking graph. Got a vertical asymptote in there. What I'm going to do is, when I trace 4, it should say that it's undefined, which it is. But I want to chase numbers right around 4. So let's try 3.99, and hopefully I'm close to 5. We'll take a look, 5.004. Let's try a number just past 4. Let's trace 4.001. Again, I'm right around 5. So I confirmed it through my graph. Okay, that is it for today. Have a wonderful day. I'll talk to you guys later. Bye.